Today it will be slightly different compared to older MDTools webinar. I start from Manifold Edge, which is actually our cloud application where our customer can share design made with MDTools and HydroCAD to vendors and customer. I'm showing you a manifold diagram that has been used in the last vehicle challenge, and so this manifold has been designed by University of Cincinnati, and so I will try to design this block showing a bit of MDTools functionalities. We'll later analyze a bit more the diagram. This platform Manifold Edge allows us to share the diagram or share an assembly, being able to look at the overall step file of the assembly, and it allows us also to look at the internal of the block, so we can also study a bit how the designer in this case decided to make his manifold, how to position the valves and ports and so on. I could have really imported this manifold in MDTools and started designing from there, but I prefer really to explain a bit more how to really bring information into MDTools if you are designing blocks from a diagram on paper. During the last webinar, I've been showing how to import XML from Hydro, and so this case it will be like having the diagram made on paper, although I could really import the XML from HydroCAD. So let me bring in a whiteboard. Let me bring it here and I'll show you how we start understanding the block. So I took this whiteboard and I'm loading the diagram, just an image, so that I can analyze a bit better the diagram. So as you can see, we start with a pump and we have the motor here. So when we design a block, we always need to think how to position our components. This block actually has been made and used in that vehicle challenge, so I can show you an image. Let me find it. So here it is. This is how the block has been made. So we can see the accumulator. Down here we can see some piping, solenoid valves. All the position for the components has been designed, of course, by the team of the university to define how to place components. In this case, I will give my version of how I will design this block. If I need to think how to position this component in my bike, I will say that this is my manifold block. Just view from one side. This is the top face. That's, let's say, the right face. And this is the front face. So I imagine that I will have my P and T ports on the right face here. So P and tank. On the front face, I will use the M1 and M2. So I will put M1 and M2 on the front face. I try to fit the accumulator directly on the manifold. So I will put the accumulator on the bottom face. Here we have the accumulator. All the solenoid valves to keep the less space in the manifold assembly. All the solenoid valves, which means item 4, 6, and 7, I will try to put on the top face. So here we'll have 4, 6, and 7. And the other valves, if possible, I will try to put in the top face. Otherwise, anything else will work. When we study a diagram, so this is with respect of a component position in the block. But when we study a diagram, we need really to check how the connections are made. So let me start analyzing a bit the net. So a net, and I've been saying multiple times during webinars, a net is really a list of connections that we have in a diagram. So if I start from the simple one, I make it red. This will be my net called P. So the P net is connecting the P port with port 1 of this valve 12. I change color and I take an orange one. And this net, I will call it P1. Then I will have a tank net. Let me take a blue line. So this net is my tank line. Then I have, let me take a yellow one, the accumulator net. That's my, let's call it accumulator. I have 2 motor nets. Let me take green for the M1. And then I take blue for M2. Then we have 2 internal nets. Let me take a gray one. Let's call the I1 and I2. Let's make it black, I2. So by using colors, really you can easily, visually, graphically understand how the connections are made. When you design manifolds with a bit of complexity, what I suggest is to build what I call a netlist, which is made manually now, and I will make it manually in an Excel file. So let me just bring in an Excel file here. And I keep it on the right, so I leave the diagram on the left. So I will have my components. And I put also the cavity, because the cavity is important in case I want to design my block. And then I have port 1, port 2, port 3. I may have port 4, 5, and 6, but in this case, the diagram is made only with 3 port cavities. So let's start listing all the cavities. I have item 4, I have item 5, item 6, item 7, item 9, 11, 12, and 13 for my manifold. Let's look and see if this is enough. So we have item 4, 5, 6, 9, 7, 11, 12, and 13. Then I have external ports, which are a pressure tank, which are P, T, accumulator, and then we have motor 1 and motor 2. And then we have some test point, which are MTP, which are MG, and then we have AG and ATP. Nothing else so far. So everything here is enough for my design. In terms of cavity, if I look at component 4, the cavity is a C10-3. So it's a C10-3. Item 5 is a C8-2. Item 6 is a C10-3. 7 is a C10-3, 2. Item 9 is a C10-2. 11 the same, copy and paste. And C8-2 is item 12 and 13. Port P is 8 SAE size, same for tank, accumulator, motor 1, and motor 2. Then we have 8 SAE size for the other ones. Sorry for going this slow analytically, but really I want to do basic and try to make everyone understand how the logic is working here. Component 4, if we look at how it is connected to M2, port 1. So port 1 will be M2, and port 2 will be tank, and port 3 will be I1, the internal net. The item 5 will be connected I1 with I2. Item 6, which is the other valve here, is taking P1, going to M1, and the port 3 is going to I2. Then we go to item 7, which is connecting P1 with accumulator. Item 9 is connecting P1 with tank. Item 11 is connecting accumulator with tank. Item 13 is connecting accumulator with tank. Item 12 is the check valve, is connecting pressure with the P port with the P1. And then we have the P net, we have the tank net, accumulator net, motor 1, motor 2, MTP is connected to motor 1, and also MG is connected to motor 1. AG is connected to accumulator net, and so on. Now that we have this table, we really can forget the diagram. We will see it later. We can keep this table, and this table is really how we have exploded the diagram into basic information to design our block in MDTools. What I do further in order later to be able to relate to this diagram, to this color, I will start my design. Today I'm going to design with Inventor because last MDTools webinar was made with SolidWorks. So I'm sorry for the SolidWorks user, but as always, the commands are the same, so there will be no much difference in terms of what I'm doing. In the options, MDTools options, when I am inside a part, I will open the settings and I go to cavity color because I want to define the colors according to really what I have drawn in that diagram. Let me reduce a bit the window and open the settings. So in the cavity color, I have a net code P, which is red, it's fine. I have a P1, which is orange, is fine. I want an accumulator net, which will be yellow. I want a motor 1 network, which is green. I think there is already one. M1, let me change it into green. M2 will be blue. You could also change the net later in the design, but really now I'm showing you that it is possible to customize MDTools so that every time you place a net with the name that you need, you will have always the same color. The tank is light blue, it's okay. The accumulator is yellow, and I don't think we have anything else. Yes, we have the internal one, which we make it gray. It's not a nice color, gray, we'll see later. And I2, we make it black. And we apply. So now we have created, modified the standard color table for our MDTools environment. What I'm going to do now is I'm going to define the type of plugs I need in my design. So normally I use BSP plugs. In this case, I'll use skew plugs, but a standard short ports plug. So SA plugs, short ports number 2, 3, and 4. This manifold is really for a bike, so I don't expect to use much large plugs. I will stay with number 2 and number 4, probably not much more than that. So I add my plugs and close. And that's it for the setting now. And I apply. Now I start placing my components. And I keep this table on the left. Later I will switch it off, but now let's keep it because it's important to understand how to place the components in the block. As always, I start the design by creating a block, and I'll try to make it small. Let's say I want to stay in a 100mm cube. I was saying, if you remember, when I sketched I was willing to put PNT port on the right. So I will go to my cavity library. I'll take my P port. It's SA ports -8. So the net for the P port is net P, and this is where we put the net P. So let me do it slowly. Let me highlight with some colors. So the net P, the cavity is -8 SAE, and the component ID is P. And we place it somewhere here. Not important where I place it, then I will play and connect in order to make it properly. As you see, color red like I had in the diagram. Then I go for tank, then that's the tank net, and that's the T port, and I place it somewhere here. I wanted M1 and M2 on the front face, so I go and take my, it's a pressure line, M1, and I place it somewhere here. Not important where, and M2. And I insert it somewhere here. The accumulator on the bottom face, so accumulator, and I insert down here. Let's put in the center, 50-50. If possible, I'll try to fit it there. Then I start placing the components. There were some sonar valves, these ones. So let's look for, in all libraries, I need the cavity C10-3. That's my cavity. That's a three-way cavity. So the component is number 4. Port 1 is the net called I1. Port number 2 is the tank. And port number 3 is, sorry, I took port 1 is M2. Port 2 is tank. And port 3 is I3. So it was not made on purpose, but as you understand, when you try to fill in this data manually, you need to pay attention. When you design starting from a HydroCAD diagram, you import directly an XML file. So all this operation, which I'm trying to do as quickly as possible, really, which is taking time during this presentation, really it's reduced. That operation is error-free if you have made properly all the connection in the diagram. I place randomly, no problem. Let me take item 6. Port 1 is P1, port 2 is M1, and port 3 is I2, and place it here. Let me start adding some engravings. So I use this command, engravings. I want to attach an engraving to the tank port and place it here, engrave. Then I want to attach to this port and place it here. And then I want to attach to this port again. I also need engravings for the valves so that it's easier than to relate them. Engrave, attach, engrave. I can start now placing, connecting, doing some. So as you see, the color, same color means I need to connect those cavities. So M1 and M2 do not look in a good position here. I can swap cavities. So I swap 4 with 6. And now I can connect 4 with M2. Let me connect in the center. And I put it here. Let me connect with a 10mm diameter. This manifold will not have much flow, so we don't need large drills. 10mm will be enough. So now I want to copy, match properties, copy this drill, the bottom drill, with the other cavities. So let me put 10mm everywhere. I copy the diameter. So now everything is going to 10mm. M1 will be connected to the green one, so I do connect to port number 2. And my block start having some shape. So P2, the P port, is connected to a cavity, to a check valve, item 12. So let's find the cavity C8-2. And this valve was taking the oil from port 1, P, and sending to P1, and the component ID is item 12. Insert. Let me place it somewhere here and connect to the red in the center, and I put it here. Now I see the orange. The orange will be connected with the other orange net. So I will need a construction port probably. Let's start placing other valves here. So we take valve number 5. 5 is a C8-2 connecting I1 with I2. I1 with I2. Insert. Let me place it somewhere here. And we see some colors. I think port 3. I2, not I1. Sorry, I was expecting a different color. Yes, gray must be connected with that gray. I try to change phase to this cavity and place it here because I need to connect the dark gray. So I will need a construction port on port number 3. It's taking a short port number 3. I just need it. Number 2 is enough in this case. And I place on this face and click OK. I can stretch this drill and making the connection. Now I want to connect the black export. I connect item port number 3, again a short port number 2 on this face, and I make it tangent. Looks okay. I should be able also to stretch and make this connection here. While designing, I can also start making the assembly. There is another solenoid valve, which let me get back to the diagram. It was item 7. So let me take that item 7. And item 7 is a C, I think it was a C10-2 or a C8. Let me double check. C10-2, yes, good. So item 7 is a C10-2. So let me take the cavity C10-2, item 7, and the port 1 is accumulator and port 2 is a tank. And I insert it somewhere. Let me put it on the top face. Now I see that I have some connection. Everything is really squeezed. So I don't like this red connection. Let me try to make some room here. I can move multiple. I can move all these 2 cavities down. I can move my drill here up. And I can shorten this drill. So by doing that, really I have a clear, easier connection. So this valve now can be moved to the left. So in order to reduce the drill, and I can connect directly these 2 ports. So in this way, I have room here. The yellow is now okay in this position. Let me move it slightly. These 3 are solenoid valves, so they will have some interference with the coil, and we'll see later in the assembly. So I will use move multiple again to move these 2 valves down on the Z direction. And now I will stretch my drill to make the connection. And I also can reduce this drill. Here, as you see, we have not enough wall thickness. We can do a wall thickness check around these cavities, well, between these 2 cavities in this case, start, and there is only 1.633 millimeter wall thickness. So this is not good. And when you see these problems, it's better you immediately address. So let me just move this cavity slightly up, 1-2 millimeter up. And later I will move this one down a bit. Let's start building the assembly. I want to check that these coils will not interfere. Well, since I have some room here, I will move this cavity slightly to the front direction. And let me save my block. That's my block number 1. Let me make full screen, and I start making a new assembly. I did not look at the bill of material. In this case, I will use HIDAC valves. So I will start placing the components. There is no block, so I will select my block, block 1. And here I have a list of all the cavities that are now in my design. So item 6 and 7, item 6 and 4 were the directional control valve solenoid operated. So these items will require a cartridge and a coil. So I will select the CAD files. I'll take my HIDAC and I take the coil. It will be a 50 sides. I'll take the DIN connector and I'll take the valve, which is similar to a WK10C. So it's a 3-way. So first we have the valve, then we have the coil. So valve and coil. Okay. Item 7, now I don't remember. Let me get back to the diagram. Item 7 was this always HIDAC valve. So I will take select CAD files. I will go to HIDAC. That's a WS valve, and always with the same coil. Then in item 5, we have, let me double check. Item 5, we have the check valve and also item 12. So it's a check valve -8 size. So for HIDAC, the component is a RV8A01. It's a small check valve. Okay, assemble. So for now we have the coils. There is no interference, so the position looks good and compact. Of course, I miss components, but as you see, the position that I have selected is okay. We have also the plugs, so we can assemble the plugs by clicking plug. So this command will put all the corresponding plugs. In this case, I have only 2. There will be more coming during the design. So as a preliminary design, this is going good. Let me connect this one with port number 2. And well, I'm not sure I did properly here. I think, let me verify the information I put. So let me put the engraving for this valve. This is item 7. This does not look okay to me in terms of so item 7 is connected to P1, not to tank. So the port 2 is P1. I'm sorry, but yes, it looked strange. So edit. The item port 2 is P1. So it's not the tank pressure. So it's orange and must be connected down there, and we'll do the connection later. So this connection is not made here. Let's place other components. So we need, we already put the item component number 4, and let's make it blank. Component 6, component 5, component 7. We put also component 12. For 5, 6, 7, 12, we need item 9, 11, and 13. So we go back and say C10-2 is item 9, and is connecting P1 to tank, and we place it somewhere here. Then we have item 11 connecting accumulator to tank, and we place it somewhere here. Later we will see if the position is good. And then we have item 13, which is going accumulator to tank, but is a C8-2. Accumulator to tank. And we'll put it somewhere here. Now we start making our connection. So this one is good, orange with orange. Yellow with yellow is also good enough. So let's move multiple and move these 2 cavities slightly to the right. We need to connect all the tank lines. So we need also to connect the yellow one. So we do a construction port on port 1 with yellow, and we take a short port number 4 on this position. We can use a align command, so align this cavity with this one so that we have a good alignment. Although here we have the spot face are touching, but we have some room. We can move this cavity slightly to the left again. The orange connection now, it's probably the most tricky part here. We need to bring it up. This valve is really irritating me. It's not in a good position. So I change face and put it on the front face. Later we'll see if this is okay, but let's for now put it on hold somewhere. Now I have some room for the orange to go up. The tank line may be moved on a different position in the port. And I make a construction port on port number 2. I take always a small plug and put it on top face. And then I copy the same plug and connect in the orange, port number 2 with port number 1. And I want to align it, these two, so that they are center to center, and it's easier to machine them. I see a question regarding my component library. So the component library I have is built because sometimes I design blocks. I do a lot of demos, training. So every time a customer is asking, I take 3D model from a website and make the valves assemblable in MDTools. So if you need components, you can ask. I have no problem with sharing my 3D library. Of course, I'm not responsible for what you design with my library, but if I can help you, I'd be happy to share my 3D library. I have more components in Inventor, but I have also some in SolidWorks, so it will be valid also for SolidWorks users. Align this one to this one and stretch this one. I have not run any checking command here so far. So the most important in this kind of situation is the connection check. So when we are designing and we want a connection check, we want to verify that we made all the connection properly, so we don't have open net. In this case, there are several, and we'll see how MDTools is able to find all these issues. So again, to open the connection check, we just run connection and start the connection check. So there are not many actually, but a few issues. Basically, P1 is open. P1 is the orange net, and we see that it's open because the orange net is not completed. Is not completed at all. But now I have some ideas, and also the tank net is not needed, is not completed. So I will just do a change phase. I put this valve here. Now the orange is here and it's going directly there. So I can make a construction port on port number 2. I take a short port number 2 and place it here. And now I can make a connection, maybe here and slightly down. And I could move this valve slightly on the -X so that we make a connection. Orange with orange. So the orange should be fine now. Yellow looks okay. There are not, so this drill is too long. So if you notice, let me highlight. There are some drills that are exceeding, not well optimized. So we have one command that is called bend. This command is able to automatically check all the intersections and fix them. So we run it. Now MDTools is checking all depth. We run all and update. So this command is fixing all the intersections. And then as you see, it's changing the connection there. Close. Let me recolor and let me clean up my drawing. In terms of connections, I need the tank line. So I will connect my tank port with port number 2 here. A connection which is tangent on the opposite side. Looks okay. I will move down, I will move down my P ports. The tank line here is not bad. I can just make a construction port on port number 2. short port number 2. Everything would have been much easier if I had started with a larger block. But really, I want to show that it's possible to find the place if you have patience, and if you can see with your eyes how you can make connections. Then it is possible to make compact blocks. And for instance, now that I see here, I could remove material, create. I could run my create command in the length. Here, I can remove 5 millimeters. So I can even make it smaller now. I move slightly my plug to the right. And if I need, I can flash it. So I can say flash this plug, also this one, and these two, and these two, so that they will not show up in the manifold face when I'm assembling. Let's check the assembly now. I go to the assembly and I can update it. I can plug the additional plugs. And now let me go on with assembling the components. So I take the components. There were two relief valves. This item 13 was a flow regulator, just a needle valve. So I take always HIDAC. So today it's my HIDAC. It's called SD8 Strom Regel Ventil. That's just a flow control valve, needle valve. On item 11 and 9, there are relief valves. So I take HIDAC DB, Druckbegrenzungsventil, DB10P. That's okay. And let me assemble the accumulator. So although I don't have fittings for -8, I will take a similar one. So I have BSP fitting 1x2, and I put a HIDAC accumulator, SBO 210. Sorry, I didn't select it. HIDAC. You can also search SBO search and you find it. You can see the preview. Move to the right, so fitting and accumulator. Update. And this is how my manifold looks like, which is okay. Let's get back to the block and let's do the verification. Let's do the connection check on all the block and see what I'm missing. So the T-net is broken, and yes, I can see it. This valve is not connected to the tank, and also this one as well. So we need to do some change. Well, let's find a solution here. Again, you must be able to view with your eyes a good strategy for making the connection. So in this case, I'm doing a change. So I do a change phase of this plug on this phase. I want to keep in the same position here at 0, 0, and stretch this plug here. And this port will be moved, but I'll move it down a bit and I'll make an offset connection later because this is not in a good place. Later we'll see how it works. So as you see now, there is a problem here. So I will stretch and reduce this drill. Well, let's make it a larger one. Let's make it 15 by 20. I'll make an offset hole on this cavity, and I take a 6 millimeter offset hole, and I connect only the offset hole to the port number 2. This is a technique, really, you can make offset connections, so a main drill and an offset hole, and this is working fine. Now that I have made this trick, I can really say stretch this drill up and change phase to this plug and put maybe on the top face and connect here and here. And now I have room for a plug here and go back to the tank line, which is on this position. I'll move my P port and I copy my construction plug here and connect. And copy again, place it here and connect. In the center, well, this one I can make the connection straight. There is nothing else needed. So these valves are only relief valves, so they will not really have too much oil flow. Also in this case, they are large. I think in that case, the selection for large valve was mainly because those were available, but the application was not really needing much flow rate, so could have been used smaller valves for relief valves. Let me move the engraving M1 and 2, and now I'm going to finish the last connection for the tank. I'm just looking if there is a better way of doing the connection, but I don't. For this decision of design, as you all know, there is not one solution to a manifold, and actually you can find unlimited solution to a manifold design. So in this case, I could really find a lot of more solution. The challenge is always find a balance between how much your customer is going to pay your design compared to the time it takes to finish it. So you could live with a poor design because it's one-off and it works. But if you have a lot of pieces, you maybe go and spend hours on the design to optimize every single drill. So now instead of having a drill here, I will make a larger one here and make an offset. So I make an offset connection here. So I will replace this plug with a short port number, let's take number 4. I keep the drill depth only. I took the wrong cavity. It was not a plug, it was a port, a SA plug, short port number 4. And drill depth only. And let me move it down. 1, 2, 3, 4, 5 mm. This should be enough. I can move this cavity slightly down so I offset from the port. And I can color everything. Let's check let's do the connection check. There are some issues I already seen, but now the net are not broken. Here I have a small issue, which is called dead area to working area intersection. So this plug is entering, so this gray area, and that's why in the beginning of this webinar I said that it's better not to use gray for nets, because the gray is a dead area. So actually this plug has both issues. In this case, so there is an intersection with the working area and also an intersection here. So what I'll do is I'll move this plug slightly up and change the spot face, and this will be enough for the design. So I'll move up by 1 mm and make the spot face maybe just 1 millimeter. If I go back to the assembly, I can just update the assembly, accept, update, and plug if I'm missing other plugs. And so the other missing plugs are there. I miss only some mounting holes, which I don't put now, we have no time. What I didn't do is really another important. So in terms of importance, the connection check is the main item, because if the connection check is giving errors, maybe an open net, the manifold is 100% a scrap. There is no way it may work. You may find a way to repair, but it is for sure not correct. Wall thickness is important as well, but even if you have places where the wall thickness is not enough according to your standard, still the block may not break. So it's really more important to verify the connection. So here you see that we have some places where the wall thickness is only 2.8 millimeters. So it's here actually. With a bit of eyes, you can view it. I show you something, a different way for viewing wall thickness. That's the last information for today. Settings, miscellaneous. I use this option, so remove color from unselected cavities. And now I run the wall thickness. Honestly, I don't like this selection because it makes my design slower. So my eyes have enough familiarity with the common issues in a block so I can view them, but this mode will help with better identifying the problems in a block. So now in this mode, MDTools will remove colors, and when you touch an item, it will show you where the minimum distance is. So you can view and see where the minimum distance. So here, I don't need this large drill. I will make it smaller. Here as well, but this is not an issue. So basically, the distance is between two cavities that are connected together. So that's really not relevant. This one is more relevant because it's a distance a bit with the vertical plug, and so on. And so on.